posted on the website, and the other Kyle is taping, okay? We'll get a better system, so it's up sooner. Hmm? What?
I'll leave it to you by Friday morning. This one.
Oh,
Yeah.
okay, we'll see, maybe we even have, I
If you
brought
have
3
enough,
plugs in,
yeah.
so it might be good. Okay, so what did we do first? Do you remember what we did first on setting up the problem? I think we read through the words, okay? But let's look at the picture first. How many of you like looking at pictures first than words? Okay, so we're going to look at the picture first. We take a look at the picture. We notice it's a cylinder. It's leaning on an inclined plane. It has a cable that's attached to the ceiling. So the first thing we did, don't write these down yet because I'm going to introduce something else that we have to put in. But we looked at the picture. Then after we looked at the picture, what did we do? We read the words, right? And found what things were important in the words that we needed to know. From that, we set up what? What did we set up? A table. We set up a table. And the first column of the table represented all the forces that are present in the system. And then the second and third column represented the magnitude and direction and whether we knew them or not. And once we found out how many unknowns we had, then we knew how many equations, then we knew what equations we needed, and we knew what body we wanted to analyze. So one thing that we forgot to do, though, is the first most important thing in setting up a problem, is you always write the given and the find. Okay? So, for the steps on doing setting up the problem, I'm going to number these. The first thing is what is given and what is find. What do I need to find? And the given represents all info not in the picture. Should I say sketch instead of picture? Let's say sketch. So in this problem, when we looked at the picture, what information was given in the words that they didn't show in the picture? I don't know where we stopped. So Evan, you're going to be the first one. We're going to go around. What information is given in the words that's not given in the picture?
The weight.
The weight, 500 pounds. Anything else? Well, it says it's homogeneous, which is important. It's flexible, smooth inclined planes. We know there's no friction. But the main number thing that we needed to know is that the weight is 500 pounds. Does everybody get it? What you write in the given is any information that's not included in the sketch. Everybody got it? So if everything is included in the sketch, what do you write in the given? Just write sketch. Just say see sketch. Okay? All right, how about find? So Isadora, looking through the words, what things did they ask us to find in this problem?
Tension.
The tension and?
And the force R.
And the force R. And what did we decide to call that force R? The normal, because it's really a normal. So we needed to find the tension and the normal. Okay? So what do we put in the find? Anything that they want us to find. So that's the first thing. Actually, you know what? Could I change this? I'm going to still look at my picture first. You look at sketch. That would be number 1. Number 2 would be read the words. And then 3 would be write the given and the find. Okay, David, what would I do next? After I write given and find, I do my? The table. I do my table. And the table has the forces, the magnitude, and the direction. And what do I use if I know the given information? If I know the magnitude of the direction, what do I put in? A check mark if it's known. And if it's not known, I put a question mark. Okay, after I do the table, what's the next step? Chris, Z. Right. I determine what the number of unknowns are, which then determines what? The number of equations I need, and that determines the number of bodies that I need to analyze. Number 6, Elliot, what do I do after that? After I know I have to do one body or two?
Some of the courses.
Not yet, I first have to draw the free body diagram. So I draw free body diagram for, well, you know what, Elliot, you're right, that here we wrote, since we had 2 unknowns and 2 equations, we knew what equations we needed and then we got the number of bodies. So you're right in a way. We draw the free body diagram for each body, and this is the total setup. After that, what comes after that?
Solving the news.
Right, all the statics equations, and I should say they're equilibrium equations, right? And what are those equations? Eric, W? What are the equations we've used so far?
Some of the forces in X, Y, Z.
Yeah, give me an equation. Equation has to have an equal sign.
Equals 0.
0. Some of the forces in the X, some of the forces in the Y, and some of the forces in the Z equals 0. So, if I have a 2-dimensional body, what's the maximum number of equations I have per body? Jill? Are you getting this on that tape or no?
I'm just getting the screen. Do you
Okay,
want
so
me
you
to?
might wanna,
Flashing.
yeah, just get that for a minute. So Jill, if we have a 2D problem, how many equations do I have? What's the number of equations per body that I have? 2, and what are they? If it's only 2-dimensional,
Some of the forces in the X and the Y.
right, equals 0, right? And if I have a 3D, Santiago, if I have a 3D problem, what's the number of equations I have per body?
You're going to have 3.
Right, and what are they?
Some of the forces in the X, Y, and Z.
Right. Equal, always say equals 0, because that's what makes it statics. Okay? So in the first problem, first thing we did is we looked at the picture. Second thing we did is we read through the words. Third thing we did, which we didn't do, but we're now realizing we didn't do, we write the given and the find. Then we draw our table. We identify all the forces, the magnitudes and directions, and we learn that there are 2 unknowns, which means I need 2 equations to solve it. In order to get 2 equations for a 2D, I need to analyze 1 free body diagram. And Armando, what did we decide to draw a free body diagram of?
Cylinder.
The cylinder, and we actually isolated it as a point, right, because it was homogeneous. Okay? And did everybody notice that the reason that we picked that point is because all the forces converge there. Tension's going up from that point, weight's going down from that point, normal's going this way towards that point. We're picking points that converge, on all the forces converge. Okay, let's look at the second problem we did. Brandon, right?
Yeah.
Okay, so first thing we do is, everybody, look at the sketch. We looked at the sketch. Second thing we did is read the words. Third thing, given and find, we didn't do. So Brandon, what was given? What information was given in the words that wasn't in the sketch? Anything?
I don't think anything.
No, it seems like they're talking about the cables, and they talk about the 500 Newton force. So everything's really in the picture. That's all I'm going to write is sketch. Fine, Brandon, since you didn't have to say anything for that one. What about find? What did I need to find?
The tensions in A, B, C, and D,
Good.
and the mass of A.
And the mass, right? So everybody take a look up here. So do I want to write it in words? I probably don't want to write tension and cable A, B, C. I don't want to write the words. I'd rather just use variables. You have to make sure that the variables you choose here are the same variables here. So We call the tension in A TA. If we call it TA here, we call it TAB. TA here. TB, TC, TD. And they wanted to know the mass, right? But here we know, what is WA going to be equal to? Tara, what is WA equal to? The mass times weight is equal to mass times? Right, gravitational acceleration, G. So whenever you use a variable, once you select what you want to call that variable, what you want to call that force, you've got to make sure that you're using that same variable. So if you call it TA here, you have to call it TA here, and when you do all the equations, you have to call it TA. So everybody got that? Okay, you want to be consistent. Okay, so we did the given and find. After given and find, we drew our table. We listed all the forces present, which directions and magnitudes were known and unknown. We saw that we had 4 unknowns, which means we needed 4 equations. Is this a 2D or a 3D problem, Chris? 2D. So how many equations can I get from each body? Only 2, but we needed 4 equations, so how many bodies did I need? 2 bodies. And Hughes, why do you think everybody chose it? I think it was Wes. I think Wes chose point 1, joint 1, and joint 2, or link 1 and 2. Why choose point 1 and point 2?
All the forces converge on those 2 points.
All the forces converge. So at point 1, I have TC going out, I have TA, I have 500. At 2, I have TA, B, and D. JJ, which way do I draw tension? Towards the body or away from the body? Away from the body, because the body's being pulled by the tension. If it was a compressive force, Eric, which way would I have it drawn?
Away or towards the body.
Towards the body. That's why normals are drawn towards. Any questions? What questions do you have? Okay, let's go to another problem. So this is the setup that I'm looking for the homework. Let's look at a 3D. Okay, Chris L. Walk me through this. What do I do first?
Let's go to our steps. We look at the sketch.
Okay, take a look at this thing.
Uh,
Second,
we read the words and
Okay.
figure out what information.
okay, a block is supported by a system of cables. The weight of the block is 500 newtons. Determine the tension in cable A, B, and C. What's next?
We set up. We write given and find.
And is anything given that's not in the picture?
Weight of the
The
block
weight.
is
So
500.
let's call it weight W, 500 newtons. And then remember, this picture is my sketch, right? A scratch. So I'm going to put my W here. And then find. Chris, what do we need to find?
Tension, cables A, B, and C.
Okay, so what do you want to call it?
TA, TB, TC.
TA, TB, and TC. Good. Evan, oh wait, I went that way, right? Wes, it's your turn. So what do we do next?
Write the table out.
Good. Force, magnitude, direction. What forces are present?
Wait.
Okay, wait, do we know it?
Yep.
Direction?
Yep.
Yeah. Next one?
TA.
Okay, you can keep giving me the other forces.
TB and TC.
TB and TC. Do we know their magnitudes?
No.
Nope, nope, nope. Do we know their directions?
We'll be able to solve them.
We will be able to solve for them.